what? What is a logarithm? So here we go. Now to describe what a logarithm, I had to talk about inverse functions. So we'll start with a function that you guys are very familiar with. Some linear functions right here. This is a linear function. It takes whatever you plug in and divides it by 5. What x values would you want to pick for this? I mean, you don't want to pick random ones. You could, but we like pretty things, and so let's try to pick pretty numbers.
20.
Okay, so some x values. Give me a -1 first, so we can stay in order here.
-5.
-5 sounds good. Give me another one.
-10.
Let's go in order. 0. Yeah. Next one.
5.
5 sounds good. Next one.
10.
All right. Why do we pick those numbers? Because they're all divisible by 5. And so we say, what is our y's? What are our y's? We get -1 right there. We get 0 right there. We get 1, and we get 2. Right? Is that right? Yeah, that's right. So if I go to graph this, at -5 I'm at 1. At 0 I'm at 0. Is that right?
Yeah.
No, I made a mistake. At -5 I'm at -1. At 0 I'm at 0. At 5 I'm at +1. And at 10 I'm at 2. Oh, this is a very slow increasing line. Oh, dang it. Slow increasing. Dang it. It should be a straight line. Oh, wow. Okay, pretend they go through all the points. This is a linear function. And whenever we graph, what are they called? Inverse functions. They reflect. They reflect about this axis right here. This axis is, I don't know, I always think of it as like the perfect diagonal axis because it's really pretty because the slope is up 1, right 1.
Is that y equals
And
x?
yeah, it's just y equals x. An inverse function would reflect about the y equals x axis because it's almost like the y's and the x's switch places. Let me show you. So if my function was x divided by 5, what would be the inverse of that? We write it like this. We write f to the -1. That means inverse of this f function. What would be the inverse of x divided by 5? Nope, it would be 5 times x. It's that you got to think inverse operations. Okay, so what's the opposite operation to division? It's multiplication, and so we're going to go 5 times x. Now let's pick some x numbers, kind of like what we did last time. Give me some x numbers.
1.
1, right?
-1.
-1. Okay.
0.
0,
1.
1,
2.
and 2. How come we're not picking the same x numbers as this one?
Because that'd be really big numbers.
They would be really big numbers. We have to kind of be intuitive, look into the future, which x numbers would give us good y numbers, so we can graph them. If I plug in -1, I'm going to get -5. If I plug in 0, I'm going to get 0. If I plug in 1, I'm going to get
5.
and if I plug in 2, 10. Now you should notice something looking at these two tables. Okay, now when I graph it, check this out. -1 goes down to -5, so I go down to here. And then 0 goes to 0. And then 1 goes up to 5. And 2 goes up to 10. So you see how like this blue line right here just kind of flips around the y equals x axis? Does that make sense? Or y equals x line, I should say. I guess it's not really an axis, but it's kind of like an axis because it spins around it. All right, you should notice that all the y's here are the x's here. You should see that. And all the x's here are the y's right here. They switched places. Okay, so what about our exponential graphs? Our exponential functions, do they have inverses? Absolutely. Okay, so let's graph this exponential function. It's kind of like our baby. It's the one we like to start with. We have x, y. Give me some x numbers here.
1.
Start with negative. I should just pick them. -1, 0, and 1 and 2. Okay, because there's no transformations going on here, I can just stick with those. It'll give me a nice shape. If I plug in -1, I get 1/3. If I plug in 0, I get 1. If I plug in 1, I get 3. If I plug in 2, I get 9. And so when I graph it, it looks something like this. -1 goes all the way up to 1/3. 0 goes up to 1. 1 goes up to 3. And 2 goes all the way up to 9. It shoots up to 9. It's an exponential function. And so we go like this and go, yeah. Okay, boom. What is my asymptote for this guy?
0.
Y equals 0. Very nice. And what's my range? Starts at 0 and goes to
Infinity.
positive infinity. My domain, all real numbers. You can plug in anything you want here. Now before I show you guys what my inverse function would look like, what would the table look like? You guys should be able to tell me that.
Wait, table. Oh.
What would be the first x that you would want to pick? Yeah, you'd want to pick a third. And that would give you what? -1. Right? Shouldn't they switch? So if I pick a 1 for this, what should the y be? Jamal? 0. If I pick a 3, what should the y be? 1. And if I pick a 9, what should the y be? 2. So if I graph this, let's see what it looks like. At 1/3 -1, we got this point right here. And then at 1, 0, we got that point. 3, 1, we have that point. And then at 9, 2, we got that point. And so this is what our function looks like. So it still reflects about the y equals x axis. What is my asymptote? That's tricky. Is it? What's my asymptote this time?
What?
3. It's equals 0 because it's right here. Let's draw. We'll draw a pink one. Here's my asymptote. What is it? Yes. It is x equals 0. Oh, switch. Instead of horizontal, now it's vertical because it's a logarithm. What's my range? Ooh, this one's different. What can my range equal? Yeah, -infinity to positive infinity.
How are they asymptotes?
I'll show you in a second.
0.
And the domain starts at 0, goes to positive infinity. All right, so there you have it. Logarithms are inverses of exponential functions. Now, how do we actually write them? Well, we write log, and then base. What's my base number? What's my base for this exponential function? What's my base number? Yeah, base 3 of x. And the x is normal size, the 3 is subscript. It's supposed to be smaller. So this is the way your logarithmic functions look, and they are inverses of exponential functions.
He sounds like you.
So, here, write this down. This is the logarithmic function. It's kind of like a template, the common function, kind of like I gave you guys with the exponential function. Let me talk through it really quick. It says y equals log base a of x. That's how you say these. Log base a of x. The a has to be greater than 0, and it cannot equal 1. It's kind of like the a when we were looking at the exponential function. The a has to be positive, and it cannot equal 1. There's another rule, though, for the logarithms, and that's that the x has to be greater than 0. You cannot plug in a negative number into a logarithm. Okay, can't do it.
What is a?
So let's practice. We got to practice going from exponential form to logarithmic form. Now, I don't think that this is a crazy difficult thing as long as you know how to read logarithms. Here, check this out. This says log base 5 of 25 equals 2. So if I change this back into exponential form, what's my base number? 5. And this is the part that's not very mathematical. I always think of it like this. The 25 and the 2 switch places. And so it goes 5 to the second power equals 25. Does that make sense?
No. What?
See, if you go log base 5 of 25, that equals 2. Because 5 raised to the 2 equals 25.
Will it always be like that?
Always. It'll always be like that.
So
What
it's
is...
like with
Here,
log-
you guys try the second one. What is the base number for this?
3.
It is 3. What's the exponent?
4.
-4, and that equals
81.
1 over 81. Remember, because it's negative, it'll drop it as if you were hot.
That's all we write?
That's it. All we're doing is writing from logarithmic to exponential form. That's it. We're translating here. All right, what about this one? Can we write this in logarithmic form?
Yes, we can.
Log base, what?
3.
Base 3 of 81 equals
4.
4. It always equals the exponent. You guys see if you can do the next one. I'll pause it. Okay, so we write log. What's my base?
25.
Base 25, right? Of 5 equals 1/2. Now sometimes people put, and I like doing this, like putting parentheses around the of number because that's inside the logarithm. It kind of helps you see, oh, this is inside the logarithm. So now, hopefully you guys can tell me what the answer to this is. What is that? What is log base 3 of 9? Now this is what you have to ask yourself. Now this is your question mark right now. You have to ask yourself, base 3 of to the question mark equals 9. So what is that?
2. Oh yeah, sorry.
Yeah, it'd be 2. It takes practice, guys. I know, you've never seen it before like this. Okay, let's try this one. What is log base 2 of 32?
16 isn't 30.
So let me translate it to help you out. Here's your question mark. It's 2 raised to the question mark equals 32. Remember, exponential.
5.
Yes, it's 5. It's 5. Take your time and think about it. 2 raised to the 5th power gives you 32.